Alright, this video we're going to flesh out our shared domain library a little bit more with the necessary backings for our interfaces for the repositories, DTOs, etc. So let's go ahead and in our DDD folder here, we're going to add another folder here for repositories. And we're going to have another folder for DTOs. So as we saw in the last video, our DTOs, and we talked about the DTOs are really for crossing that boundary from server side to caller side, where we want to translate our domain objects into data transfer objects. And we can start by basically having our entity DTO. Again, we're going to have a public abstract class, and we're basically going to mimic the structure of our entity, which has an ID. So a couple things to point out first, though. So as I added that ID property, there are two things probably might jump out. One is the fact that it's nullable, and over on our actual entity, it's not nullable. So why the difference? Because when DTOs are not only for it's for crossing the boundary between client, the caller, and the actual API. However, it may be coming inbound or outbound. So we might be sending back a DTO in a response to the caller, or the caller might have actually passed us a DTO. And there are cases where they're going to send us an object to create, but that hasn't been assigned an ID yet. So therefore, because it's both inbound and outbound, we're going to have an entity DTO where the ID might be null because it might be coming inbound. If it's something we're sending outbound, then we'll definitely have the ID. We will have assigned it, and we can send that back to the client. But we want to represent both sides of the equation there. So we're going to have constructors that mimic what we saw on the entity object itself in the domain world, but we're also going to have a slight difference here in the sense that, again, the ID is nullable, and in our business object base class for entity, we were assigning a GUID, but we're not going to do that here this time because, again, it could be in the default constructor. Because this is nullable, we don't want to assign this a value. We want to maintain the fact that it's null originally. So there's our base class for any sort of entity DTO, and we can create an aggregate DTO class now as well. And the aggregate DTO, similar to what we saw for our domain objects, is really just going to inherit its functionality from the entity DTO. And so we just need our constructors. So there's our constructor where we don't take any sort of ID inbound. Then we'll have one where we do. And we pass that along to the entity constructor as well. That's it for our aggregate DTO. All right, the next thing we're going to implement is an interface that our repositories are going to be able to implement. And is going to be sort of the base interface for all of our interfaces that we create for the real repositories. Like we saw in the last video, we started to create our product repository. So we want a base interface that it can inherit from. So we're going to start off by just having IRepository. This is actually going to be a public interface. And the repository is the means by which we're going to be able to get things from our persistence layer or store them via the persistence layer. So typical things that you're going to want here, and sorry, I should have also included our T. And the important thing here is where T is aggregate root. So as we talked about, our in domain-driven development, the only things that can be stored and persisted and retrieved from the persistence layer are aggregate routes. So whenever we're building out an interface for a repository, we want the repository that we're building it for has to be for an aggregate route. Hence our where T is an aggregate route. So we're going to need a method by which we can get a particular entity by its aggregate route by its ID. We're going to want an insert. We're going to want, and I'm going to save myself a little bit of typing here, an update, and we're going to want to delete. So for all of our repositories, these are the 4 basic methods we want to make sure that we have: the get by ID, insert, update, and delete. There's one other one that I sometimes include in the base interface itself. I'm not going to include it for the moment, which is a get all. If you have a get all, obviously that's intended to retrieve all the objects of that type from the database, but I think including on every repository can be a bit dangerous in that there might be some objects or aggregate routes that there's going to be a ton of objects in the database. Therefore, implementing a get all could encourage somebody, if it's there, I can use it, when in fact you may not want them using that kind of method to retrieve if the table is very large. So these are our basic methods that we're going to start with on our repository class. So the other thing that we've got to talk about is the unit of work. So the whole idea, for those that are not familiar with the unit of work pattern, the idea is when a request comes in from a client and we may have to touch multiple tables, multiple objects, and the persistence layer, making updates, creations, inserts, deletes, etc., we need a transaction, right? So a transaction that covers all of that, so that if a part of it has already been completed, if our call requires 2 inserts into 2 separate tables, if the first insert is successful and then the second one fails, we want to roll back that first insert so that we're leaving the database in a consistent and consistent state. So we need a mechanism by which we can control all of that. That is something that is controlling the transaction, and something that is also going to be responsible for, once all of our database work is essentially done, or right before we're about to commit all the changes. So we've made the changes with our inserts and updates, but we haven't committed them yet. We haven't committed the transaction. That's the point at which we want to issue all of our domain events that might have occurred during the transaction. So when the call arrives at the server, we got some work to do in terms of some inserts, updates, deletes in the database, and then those changes that we've made to our domain model may issue domain events. And the domain events are ways that you can handle side effects of, when this particular object is created, inserted, or updated, that we want something else to happen as a side effect of that, some other code that we might want to run. And that's going to be achieved through domain events. And so while all this activity and this business logic is going on, some domain events could be piling up as the changes are occurring, and then we need a point at which we actually call or issue those domain events, and then anybody who's subscribing to and then handling those domain events need an opportunity to run within the same transaction as well. So we need something by which all of that is being managed for us, and so there's a unit of work pattern, and so there's a unit of work object. Basically, when the request arrives at the server, we are going to start a unit of work. And then when the request is done being responded to, we are going to complete our unit of work. We will either commit the changes or roll back the changes that have occurred because of that request. So basically, the lifespan of a unit of work is the lifespan of the request that we're reacting to. So the transaction should start when the request arrives at the server, and then the transaction should complete when we're getting ready to send the response back. And when we complete it, we're either going to commit the changes we've made, or we might be rolling them back. And so the unit of work is the owner of all of those different aspects. And so we need a unit of work interface, which is what we're going to create here. It's going to be a public interface, and it's going to have several responsibilities. One thing that I like to do on the unit of work is actually give it an ID. Sometimes through dependency injection, which we'll be getting into and talking about, you want to be able to test, hey, is this unit of work really the same unit of work that I saw over in this other class that was passed into this other repository? And to verify those kinds of things, it's really helpful to have an ID on the unit of work. Therefore, you can say, all right, if I'm in service class A and repository A, repository B, and I see they both received through dependency injection a unit of work, and I want to know, are they really the same unit of work? I can check the ID just to verify. So it's really for debugging purposes, but we're going to include one here. So we're going to assign a GUID ID. And then our unit of work is in charge of the transaction. So we need an ability to commit our transaction. We need an ability to roll back our transaction. And we're going to see, as I mentioned, that it's also going to be responsible for releasing into the wild all of our domain events right before we commit or roll back. Now there's another attribute that I like to include in the unit of work, which is giving it the ability to, for a given call, and that's it, cache certain objects. So if a request arrives at the server and I'm going into the database to get one or more objects, there might be multiple service handlers, service classes that end up calling and asking for the same objects multiple times. And in those cases, I don't want to go to the database every single time. If I've already loaded one of those objects from the database, I just want to be able to, hand back the same object I've already retrieved. Now, this is caching in the sense of caching at the unit of work level. So for a given single request, this isn't caching as it relates to caching across different requests, right? So if there's a separate request coming from the client and we want to return a response that we just returned, a couple minutes ago for either the same client or a different client, that's a different level of caching, and we'll get into that. What I'm talking about here is specifically just for answering a single request. So within the context of a single request and response, therefore within the context of a single unit of work, being able to cache certain objects that I've already gotten from the database and respond with those to prevent going to the database multiple times. So for that, we're going to have an ability to put something into the cache. So we're going to have cache entity, and what we're caching is an aggregate root. And then we're going to have the ability to remove an item from the cache. And then we need different abilities by which to get things from the cache. So we're going to get cached entity. We're going to have a method where we can do it by its ID. And then we're also going to have a method where we can actually pass in a function that will allow us to find a given aggregate root based on some sort of filtering function. The other piece we're going to need here is, so when we're dealing with a transaction, we actually need access to that transaction. So the unit of work, if it's managing the transaction, has to have knowledge of the transaction and what state the transaction is in. And what we're going to end up using is a micro ORM, and the transaction is actually going to be given to us by the micro ORM, and the micro ORM basically has something called a session. So we're going to have a get property that will give us back our session, and we're just going to treat that as a generic object for the moment. So that's our unit of work. That's going to be responsible again for starting and completing transactions and keeping track of what objects we've already retrieved from the database for a given request, and therefore allow us to use a cached version if it's asked for a second, a third, or so on time. And then we're also going to, the unit of work will be responsible for issuing domain events. So we have an add domain events, which is basically whenever an object is being passed to a repository for insertion, update, etc. During those inserts and updates, it's going to take all of the domain events that are related with that object that is being inserted or updated or deleted and add them to the collection of domain events on the unit of work. So that the unit of work, by the end of all of the database activity, will have a complete list across all objects that have changed in some fashion that have domain events. We're going to be able to aggregate them all at the unit of work level, and the unit of work will take care of actually issuing out those domain events. Hence the add domain events, which we'll see when we implement some of our repositories. So that's our interface for the IRepository. So we've got our DTOs for aggregate root entity. We've implemented our IRepository. There's still a few more things, little things that we're going to come back and we're going to implement sort of on an as-needed basis here in this shared library, but it's starting to take shape. So why don't we do one more thing, which is come into the iProduct repository that we had started the implementation of in the last video. And we are just simply going to have it implement IRepository for product. Now, just to drive the point home, one thing I'll do real quick is let me come over here to product and make it no longer an aggregate root, and let's just say it inherits from entity. If I come back here and wait a moment here, all of a sudden we do get a compiler error saying, like, wait a minute, you have an IRepository interface that you're implementing for product, but product's not an aggregate root. That's not allowed. Aggregate roots are the only thing that can move in and out of persistence layer through repositories. So hence the error there with that. Let's come back over here. Defined here by the where our generic type T must be of type aggregate root. All right, so let's just change this back before we wrap up this video. And so, yeah, we've started to flesh this out. In the next video, we're going to start taking a look further at implementing the implementation layer, which is going to cause us to actually work on a new shared library, which is going to be the shared library for the infrastructure level, where we're going to take a lot of these IUnitOfWork interface and IRepository interfaces and actually create a base class that implements those interfaces that's going to make life of implementing our actual repositories for things like the product much simpler. So we'll take a look at that next, and stay tuned. Time for a shameless plug for my personal LLC, Keystone Code. I've been doing software development for 20 plus years now, and I've been lucky enough that I've played a lot of the different roles that go into software development, from back-end developer, front-end developer, full-stack developer, team lead, head of engineering, chief technology officer, business analyst, and architect. So if your agency or company has any needs across those different areas, whether it be a need from just understanding what those roles are, or have a need to fill one of those roles, either from a training perspective, a mentor perspective, or an actual hands-on perspective, feel free to reach out. So I can be reached at my email address, dmichael@keystonecode.com, or on the website at keystonecode.com. Thanks.